we have finished going over factoring, and so Chapter 11, starting with 11.1, 11.1 really has two different techniques embedded in it. The first one is called the square root property. So in our little overview, I wrote that down, the square root property. And I said that it was kind of specific when it can be used. It can be used when you have a problem that looks like x squared is equal to some number. So it can be used when you have a problem that looks like that, or when you have x plus something quantity squared equals a number. Now, this parentheses can be pretty complicated, but it has to be, to use this square root property, one of the sides has to just be a quantity squared equals just a number. So you're going to see that in every one of these problems. Now, I may have, in embedding these questions in here, I may have chopped off part of the question, but I'll fill it in. Problem number 1. It says, use the square root property to solve the equation. The equation has real solutions. Okay, now before the lesson is over, we may have some that have imaginary solutions, but we visited those numbers yesterday. Okay, this particular problem starts out x squared equals 4. So my first question would be, is it in the right format to use the square root property? The answer is yes. What you do when you use the square root property is you take the square root of the left side, you get x. You take the positive and the negative square roots of the right side. Now there is a little process to explain why you are taking the positive and the negative square roots, and I usually save that for a discussion in college algebra. So for right now, and because we're a little bit crunched on time, I'm not really going to justify why we've got that plus or minus. If you want to visit with me about it, I'll be glad to. But it is your job to remember that you're going to have the plus or minus. Remember, you need two answers to a quadratic. That's where the two are going to come from. Now, at this point, you need to always ask if you can simplify this radical. So that's a question. Can you simplify it? Well, do you know what the square roots of 4 are? 2. So the answers are x is equal to plus or minus plain old rational 2. Now when you do some work for me, or literally for any math teacher, it would be acceptable to have this little combination symbol that says plus or minus, which is just a compound way of saying the two answers. My math lab doesn't have that symbol. So it says type exact answers using radicals as needed. We don't need any. Use a comma to separate. So what you would have in my math lab is x equals 2, negative 2. So you don't get to put the combined version in my math lab because it doesn't have that symbol. But you are welcome to do that for me. Is that okay? All right. Now, what you're going to see in the next few problems is that maybe the format will get mixed up a little bit, and perhaps simplifying this radical will take on a different approach. So let's look at number 2. Once again, it says use the square root property, and the problem is x squared minus 21 is equal to 0. Well, is this in the right format for the square root property? No, because it has to be something squared equals a number. So I'm going to add 21 to both sides, and I'll end up with x squared is equal to 21. Is it now in the right form for the square root property? Yes. Take the square root of the left side and I get x. Take the plus or minus square roots of 21. And what do you have to ask yourself? Can you simplify that? The answer is no. First of all, 21 is not a perfect square. Secondly, is there a perfect square that goes into it? Well, there's just 7 and 3, and they're not perfect squares. So this answer is finished as far as I'm concerned. My math lab would want x is equal to the square root of 21, comma, the negative square root of 21. Okay, so sometimes you have a perfect square, you take the square root and you get rational answers. Sometimes you have a square root that you can't even simplify and you just leave it. All right, let's look at number 3. Once again, you're asked to use the square root property, and we have x squared is equal to 18. First question. If you're supposed to use the square root property, is it in the right format? Yes. So I will take the square root of the left side and get x, take the plus or minus square roots of 18. And then always ask yourself, can I simplify that? Well, I'm going to go off to the side and do that. The square root of 18, would you help me out with factors? 9 and 2. 9 is the perfect square. 2 is not perfect. The square root of 9 is 3 times the square root of 2. So I'll send this back in the place of the square root of 18, and I get x is equal to plus or minus 3 times the square root of 2. Having talked to a college algebra teacher, and I am a college algebra teacher also, and I said something about, yeah, I'm working with quadratics today, and she said, oh, please make sure they can handle radicals. That is really a point of frustration in the class, is when they don't know how to handle radicals. Somehow a lot of students take college algebra without going through this class and don't have the background. So they're at a deficit, and you should be fine. Keep in mind that my math lab would want x is equal to 3 times the square root of 2 and negative 3 times the square root of 2, since it doesn't have that combined symbol. Okay, so we're working on the square root property. All right, problem number 4. I think I'm going to copy it down on some blank lines, and it is x plus 8 quantity squared is equal to 16. Is that equation ready for the square root property? Well, does it have something squared equal to a number? Then it is. Okay, that's what it takes. So I take the square root of the left side. Now when you take the square root of something squared, it comes out of the exponent. There's no exponent anymore. And that equals plus or minus the square roots of 16. Can you simplify the square roots of 16? So I have x plus 8 is equal to plus or minus the rational number 4. In my earlier first 3 problems, I was done at this point. But I'm not done because it doesn't say x equals yet. So I'm going to subtract 8. Now, if you'll kind of watch carefully, when I put the minus 8, I think you're going to be a whole lot safer if you put it in front of the plus or minus symbol. So you have x is equal to negative 8 plus or minus 4. I've just seen a lot of mistakes happen when it's put behind it. All right. Because 4 is a rational number, I can actually get 2 answers, 2 distinct rational answers, because one of them is negative 8 plus 4, and one of them is negative 8 minus 4. One of them I add a 4, and one of them I subtract a 4. So the top one, that's going to give me what? negative 4. And the bottom one, they're both negative, so add them up for negative 12. Negative 4 and negative 12. So you don't always get opposites. You don't always get 3 and negative 3, 5 and negative 5. Sometimes you get two very different answers. So with this, I took the plus sign for one of them, and I took the minus sign for the other one, and I did my arithmetic. Is everybody okay? All right.
One was like square root of 2. You just subtract an x, but part that's outside of that.
Actually, it will do one in just a second. You'll actually just leave it right here. Okay, but I will answer that question. Let's go back and see if I can, yeah, we'll see it in number 5. X minus 5 quantity squared is 8. All right, does this problem look like we should be using the square root property? Something squared equals a constant number. Okay, so I jump in and use the square root property. I get x minus 5 is equal to plus or minus the square root of 8. Now, 8's not a perfect square. Can you simplify the square root of 8? I hope so, yes. It is the square root of 4 times the square root of 2, which is 2 times the square root of 2. So now I'm about to really answer your question about how you finish these problems. So I have x minus 5 is equal to plus or minus 2 times the square root of 2. Now I'm not quite through because it doesn't say x equals yet, so I'll add 5. I'd like to put it in front of that symbol. So I have x is equal to 5 plus or minus 2 times the square root of 2. Now this time, I can't really get two nice answers, because if I do the plus, I get 5 plus 2 square root of 2, but these are not like terms and I can't add them up. If I do the minus, I get 5 minus 2 times the square root of 2. And I can't subtract because they're not like terms. This is rational. This is the coefficient of a radical. So my math lab would want you to separate them like this, but I am completely happy with this combined answer. Now, if you go back up, why was this so different than number 4? The number sitting on the right-hand side in number 4 was a rational number, a plain old number, no radical sign. So I could perform the arithmetic, and I did. But in number 5, it's a radical expression, which means I can't combine it. Math Lab wants it written like this. I'm fine with you leaving it combined. Does that make sense? Okay. Number 6. Yes. Okay. Leave it just a second. All right, let me see if I can get number 6. It's 2x minus 3. 2x minus 3 quantity squared is 12. Problem number 6. Even though it's getting more complicated, does it still look like the square root property? Something squared equal to a number. So I'm going to take the square root. That gives me 2x minus 3 is equal to plus or minus the square roots of 12. Can you simplify the square root of 12? Isn't it the square root of 4 times the square root of 3? Which is 2 times the square root of 3. Back to the problem. I have 2x minus 3 is equal to plus or minus 2 times the square root of 3. I'm still trying to solve for x. What will be my first step? Add 3, and I'll put it in front. So I have 2x is equal to 3 plus or minus 2 times the square root of 3. And I can't really add and subtract those because they're not alike. So I'm just going to leave it, and I have one more step. I need to divide by 2. I am completely satisfied if you tell me that the answers are 3 plus or minus 2 times the square root of 3 over 2. Once in a while you can reduce, but only if this rational number, and this rational number, all three have a common factor. Now, these two have a common factor, but all three of them don't. So you're stuck. Done. Can't reduce. What would my math lab want? It would want 3 plus 2 square root of 3 over 2, comma, 3 minus 2 square root of 3 over 2. And you know that's going to be a real pain to type in because you've got a big fraction and you've got a radical, and so you're going to have to be really careful. Okay, we have just a couple more. This would be 11.1, number 1. Part 1. And if you printed the notes, I bet you have more than about 8 questions. You have the wrong notes? Okay. The other questions don't really fit into this lesson. My fault. All right. Let's look at number 7. I have x squared plus 225 equals 0. Does this look like it's ready for the square root property? No, because it doesn't say something squared equals the number. So I'm going to subtract 225 from both sides, and I have x squared is equal to negative 225. Square root property. It's ready now. X is equal to plus or minus the square roots of negative 225. Yes. Square root of a negative number, ding, 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 you're going to have some imaginaries. Now, is 225 a perfect square? And the answer is yes. Square root of 225 is 15, I think. So x is equal to plus or minus 15i. Everybody know where the I is coming from? Because we're taking the square root of that negative 1 factor. If you were doing it from my math lab, it would be x is equal to 15i, comma, negative 15i. So square roots of negatives. I'm always okay with plus or minus in my answers. Math lab likes them separated. Okay, I think last one that is in square root property. What is that number? 7. Okay. It is x minus 7 quantity squared is equal to negative 25. Oops. All right. Is this one ready for the square root property? Yep. So I'm going to have x minus 7 is equal to plus or minus the square roots of negative 25. Can you simplify the radical? Yes. You notice that it's a negative 25, so what are the square roots? Okay, plus or minus 5i. And now I need to add 7 to both sides. I'm going to put it in front of that, and I have x is equal to 7 plus or minus 5i. Can I literally add the two numbers together? No, because this is a real part and these are imaginary. So this would be fine for me. My math lab would want x is equal to 7 plus 5i, comma, 7 minus 5i. Do you notice that those two answers are in that standard complex form of a plus bi? And that should happen. Now, answers that turn out to have imaginaries in them, answers that turn out to have radicals in them, those problems could never have been factored. Even if you got them all set equal to 0 and all that, you could never factor them. If you have a problem, though, let's see if I can find it, way back up here at number 4, where the answers turn out to be rational, -4, -12, what that means is back here, if you squared this and then subtracted the 16 and set it equal to 0, you could factor it. So if the answers turn out to be rational, that means that factoring could have worked if you had gotten it in the right form. But answers that turn out to have radicals or imaginaries never could have been factored. So now we have a technique that'll work when factoring won't. But it's real specific. It's got to have something squared equals a number. So that's the square root property. I would never ask you to use it on a problem that it wasn't appropriate for. Okay? So we're going to stop 11.1, and then we'll do our final lesson on this set.